Okay, we have today another integral. This one's from the MIT Integration Bee 2006, problem 41. We have the integral of 1 over x plus square root 1 plus x squared dx. Okay, I actually did this one two ways. I did another video on this. The other video was probably a longer method. I'll provide a link in the description to that. And the other one, we did a u substitution for the denominator. And then we rationalized this thing later. What I want to do for this one is actually rationalize the denominator first by multiplying by the conjugate. I'm going to write it this way. We'll multiply by 1 plus x squared minus x. And of course, we'll do the same thing here in the numerator. And then we'll just multiply this in. So when we rewrite this, we'll just bring over this in the numerator. So we'll have our 1 plus x squared minus x dx. Now we're going to have some nice simplification on the denominator. So first, multiplying these together, we're just going to get 1 plus x squared. And then multiplying the last terms, we're going to have a minus x squared. So then what's going to happen is the x squareds cancel out, and now we just have 1 in the denominator. But now with the simplification here and the minus sign here, we can just break this up into two integrals. So for the first one, it's just going to be square root 1 plus x squared. And the second one's just going to be x, which we can use power rule on. So this, of course, is going to be easy. But for this one, what I want to do is I want to do a trig substitution. I actually want to use the hyperbolic trig substitution on this. So what we're going to do is for the substitution for x, I'm going to substitute x equal to sinh of t. The reason why this is going to work nice, we have this identity that we can say cos squared x minus sinh squared x is just equal to 1. Then when you rearrange that, we have sinh squared x plus 1 is equal to cos squared x. So what that's going to do is it's going to allow me to get a perfect square in here. Now before we do that, let's take a derivative. So for our dx value, that's just going to be cos of t. Then now we have everything in order to do our substitution. So we'll come over here and substitute. So here we're going to have this going to become 1 plus sinh squared of t. Our dx value is this thing, so this is going to be a cos t dt. And then here we'll just use power rule on this, and we're going to have a minus x squared over 2. But then on this right here, we'll use this identity, and this thing is going to become cos squared t. Then reducing this, this is going to be absolute value cos of t. But cos is actually always positive, so we'll just remove the absolute value on this. And so what we can do, multiplying cos t times this one right here, this is going to become cos squared of t. But now on this, we can use the power reduction formula. It's really similar to the regular trig functions. On this, it's going to become 1/2 plus 1/2 cos of 2t dt. And so just going ahead and integrating this, we're going to end up here with 1/2 t plus 1/2. This is going to become sinh of 2t. But I need to bring out a 2 in the denominator, so we'll have another 1/2 here, and we'll bring along this minus x squared over 2. But now from here, I just want to reduce this sinh 2t. We've got the same double angle formula we have for the regular trig function. So what I can do here, so then let's rewrite this as 2 sinh t cos t. But now from here, we just really need to back substitute. Let's get a value for t. So just rearranging this here, I can write t as inverse sinh of x. We already have a value for sinh of t. This is the same thing as x from this right here. And then in order to get a value for cos, we can just use this right here. If you take a square root on both sides, that's going to be, this is now going to be just cos x here. But again, I'm just looking at this like the variables t on this, right? So I can just, let's just change this to t really quick. So our formula for cos t is going to be this, but for sinh t we have x. So for cos, so let's just make it clear up here. So for cos t, we can write this as square root. With this being x, we can write this as x squared plus 1, and so that's going to be our value we need there. So putting this all together for my final solution, I'm going to factor 1/2 out of everything. This here is a 1/2 too, right? So we'll factor 1/2 out of everything. T is going to be inverse sinh of x, plus here we're going to have x square root x squared plus 1 minus x squared, add a plus c, and that's it. Okay, there you have it. Good problem from MIT 2006. Thanks everyone for watching. Have a good day.